In this video, we are going to discuss about the object-oriented programming concept of inheritance and illustrate it in the Java programming language, obviously. So let's start by defining inheritance. Inheritance is a way, pretty much a technique, that allows you to form new classes based on existing one. The idea here is obviously that you write some code in a class and you want to share and reuse this code instead of doing some awful, cut and paste of the same code in multiple classes. And then as soon as you find a bug in that code, then if you did cut and paste that code into multiple classes, you would have to track down all the classes where you did that kind of cut and paste and fix the same code the same way. So that would be really tedious, right? So as you program, you always want to try to avoid repeating yourself. Okay, there is a principle in programming called the DRY principle, D-R-Y, don't repeat yourself. Okay, and that's one of the instantiation of that principle. So we want to be able to share code between classes. We want to be able to reuse code from one class into another class. Well, inheritance allows us to do that. More specifically, it allows us to specialize a class. So we have maybe a very general employee class that contains all the fields and the methods, that are relevant for an employee record that we want to store in a database and do whatever with. But then we have maybe in our company some different types of employee, and those employees, the specialized employees, they have additional method, they have different ways of doing things maybe than the generic employee. Okay, well, this is where the inheritance mechanism is going to come into play. So let's introduce a little bit of terminology here. So when we have two classes, like we were using the example of an employee and a specialized employee, let's say that a secretary is a specialized type of employee in our company. So the employee would be the most general class, okay? If we want to write the class secretary to implement, an employee record with all the additional fields and methods that are inherent to a secretary object, okay? Well, we need to call then employees a superclass. We need to have secretary be the subclass of that superclass employee. So we would say that the superclass is a parent class, the subclass is a child class, okay? The relation between them is inheritance. So we say that the secretary class inherits from the employee class, or extends the employee class, or specializes the employee class, okay? And it inherits, therefore, from all the behaviors and fields that are in that superclass, okay? Another way to look at this that is equivalent is to say that there is also a relationship. So what does that mean? Well, when you talk about a secretary object, you can say that a secretary object, which is of class secretary, is a form of employee object. Okay. So if we look at the kind of inheritance diagram that can result from this kind of stuff, we may have in our application an employee class, okay, and then we have a subclass of the superclass employee that is a lawyer, a subclass of the superclass employee that is the secretary, and we represent that relation of, subclass, superclass inherits with this arrow here, and a marketer that is a subclass of employee. And it doesn't stop there. You can have a legal secretary that pretty much is everything a secretary is, plus some fields and methods, that are additional and needed to handle the specifics of objects of that class, okay, of that type of employee. So this would be a hierarchy, an inheritance hierarchy, okay? And you can see the superclass are to the top, pointed to by arrows, and the subclasses point to their respective superclass. And you can have a chain of subclass, superclass, a chain of inheritance relationship, okay? And you can say also that to this diagram, is a relationship applies perfectly, right? A lawyer is a type of employee. A secretary is a type of employee as well. A legal secretary is a type of secretary, which is itself a type of employee. Okay, so you see how this relation, subclass, superclass, child, parent, inheritance, and is a relationship actually all reflect different aspects of the same thing. Okay. What about syntax? So let's talk a little bit about inheritance syntax. In Java, you define a class, for example, here, well, name of subclass, not really original, but this is going to be our subclass, okay? So you define a class like you did before, except that right after its name, you add the keyword extends, and then you specify the name of the superclass. So for example, public class lawyer extends employee. Okay, superclass here, subclass here. It's a specialized class extends the more generic class. The child class extends the parent class. The subclass extends the superclass. All of this terminology is completely equivalent, okay? But depending on the book you read, depending on the programmers you talk to, you're going to hear one or the other. So I want to familiarize you with all the terminologies that apply here. Now, the term extend actually really captured that notion of we are writing a new class and it's a specialized version of the more generic parent class, okay? By extending employees, the loader object can now receive a copy of every method and every field from the employee class, okay? So everything an employee object can do, a lawyer object can do. So everything the superclass can do, the subclass can do, okay? Actually, everything object of the superclass can do, object of the subclass can do as well. So everything is inherited, the methods, the fields, etc. Now, we are going to see when we talk about polymorphism that this also allows us to write code that is meant to work on employees, okay, in general. And if we ever pass an object of class lawyer to that code that is supposed to manipulate employee, well, because a lawyer is a type of employee and a lawyer feature all the method and fields of an employee, well, that object of class lawyer can be used everywhere I was using an object of class employee, okay? And then the last point here is that the lawyer class can also replace some of the methods that are already written in the class employee. And it can replace them, override them is the correct term, so that it adapts them to the specificities of that subclass, okay? So that makes it very interesting, because if you consider the two last bullet items, that means that if I write some code that is actually expecting an object of class employee, working on an object of class employee, and I call some methods that are defined in the class employee. Well, if you pass an object of class lawyer to that code, and that code starts using the same method that it was using on every other employee, maybe those methods behave the same way in the case of a lawyer, but it's very possible that whoever wrote the class lawyer adapted those methods to the specifics of a lawyer object. And in that case, my code that is using those methods, that are standard for every employee, won't even know that it's using specialized method for a lawyer. That will happen naturally without having to do additional work, okay, additional checks and stuff like that. So let's look a little bit more into overriding, because this is definitely an interesting concept, okay? So let's look at how we can make that happen in practice. So overriding means you have a method that is already written in the superclass, the most generic class, the parent class. And now you write a new class that extends that superclass, and you want to write another version of that superclass method. And this version has to be used, if you have an object of that subclass. Okay? So, good news. There's no special syntax required to override a superclass method. All right? So, let's say that we are inside of our public class lawyer that extends the class employee. Let's say that the class employee has a get vacation form method already that returns a string, and it's supposed to get us the color of the form that an employee needs to fill, to get to request some vacation time. Just contrived example here. But so if we want to override that method, we just write our own version in the class lawyer, and we use the same access public with the same return data type string, the same name for the method, and the same number and names and data type for parameters if there are any. In this case, it's very simple. We don't take any parameters. So by simply rewriting here the the name of the method, the parameters, the return type, and the access modifier here, inside the class lawyer, Java is going to understand that this method is replacing the equivalent method in the class employee. So for example, in this case, I return that the color of the vacation form for an employee that is a lawyer in my company is pink. Okay, maybe the default color for an employee was, I don't know, blue. Doesn't matter, okay? I'm overriding the behavior so that if I have an object of class lawyer and I ask get vacation form, I'm going to get the correct color. If I have an object of class employee, my code will still ask get vacation form from that object, and it will get, for example, the color blue for a traditional employee. So no matter what I am passed, whether it's an employee or if an object of class employee and an object of class lawyer, an object of class secretary, etc., if all of the subclasses do their job and override, the get vacation form method from the original superclass employee, then I don't even have to look at what kind of object I'm manipulating. I write my code saying I want to manipulate an employee, and it can be an employee or it can be any of the subclasses of employee. I don't have to care. Automatically, the overridden methods are going to trigger if they are relevant. Before we move to the next slide, let me correct something here. When this slide says no special syntax is required to override a superclass method, technically it's true, but the operational keyword is required. Okay, in Java 8, you can use something here called an annotation. The syntax is @ symbol, then a keyword after that. So we are not going to talk much about annotation right now. Okay, we'll talk about them later. But just in the context of overwriting, I want you to know that you are going to find code where the programmers have added this keyword @override in front of some method. And it's just a way to say, I am actually intentionally overriding this method in my class lawyer, okay? And actually here's an example, sorry, there's a little error here. The @override should be right here before public string get vacation form. My apologies, I'll fix that on the slide so that the PDF version of the slide contains the fix. So the @override keyword is not before the public class lawyer extend employee. No, it's inside the public class lawyer, and it's right before the method that you intend to override. Okay, that makes much more sense. So what I'm saying here with this keyword is I am writing a method here, and this is a method that override an equivalent method in the superclass. We don't have to write this. Java is going to realize that we override. So why would we care about adding this keyword here? Well, simply because it's a way for us to say my intent is to override. Now, if I wrote private instead of public, that's not going to override correctly. If I wrote string with a lowercase s, it's not going to overwrite correctly. If I write int or void actually as return type, then it's definitely not going to overwrite correctly, but it's not going to even raise a compilation error. A string with lowercase s would. If I spell the get vacation form with a mistake, like for example, I forgot the R in form, it's not going to override correctly, right? So all of those little mistakes that a programmer can easily make, the problem with them is that they are going to go silent. Even though you meant to override a method from your superclass, if you did any one of those typos when you wrote the overridden version, then Java is going to say, wait a minute, this is not the same method. So you are not overriding get vacation form. You are just providing me with a new method, let's say get vacation from, and the R is missing. And Java has no way to know that this is a mistake, because maybe there's another method, get vacation from, that is actually relevant, okay? Java doesn't understand what you're doing in your code, right? So putting the keyword override right before the line of where you start your method here allows Java to know that you actually intend to override a superclass method. So if it finds that there is no superclass method that matches the name that you put here, for example, or the name plus the return type or the list of parameters, etc., then it's going to raise a mistake, an error at compilation time. It's going to tell you there is a problem. You told me you were trying to override something. I cannot find it. So it's kind of an added safety. Okay, it's not required. It's just something nice to do every time you override a method, so as to enable the Java compiler to catch some easy mistakes, okay, that would otherwise go silent. So let's talk now about how our superclasses are going to be able to use that code that's present in the, sorry, let me rewind here. Let's talk now about how our subclasses are going to be able to use the code that we defined in our superclasses. We said that the whole point of inheritance is we don't want to repeat ourselves, we want to share code. Okay, so let's say that we are writing that lawyer subclass or that secretary subclass. Both of them inherit from employee. There are some methods in employee. How do we call them? The syntax is very easy. When you are writing code inside the method of your subclass, you can use the keyword super, like superclass, super dot and the name of a method, and then pass parameters to it. And that is how you can, inside of your subclass, inside of a method of your subclass, call another method from your superclass and pass to it parameters. If you are trying to call a constructor from your superclass from the constructor in your subclass, same way, the syntax is reminiscent of what we already talked about for the des keyword, okay? So you use this time the super keyword, parentheses, parameters, parentheses, and that's going to call the constructor of your superclass from inside the constructor of your subclass. Let's take an example. Public class lawyer extends employee, okay? So here's my constructor. Public lawyer takes a name. I don't do anything, really. All I do is, well, there is already a constructor for employee. This constructor happens to take the same type of parameter I take here, so a name. That is a string. So I'm just going to call the constructor of the superclass employee and pass the name to it. And there we go. Okay. Here's another example. Public double get salary. So it's a method defined inside my subclass lawyer. I first obtain what the base salary of this employee is. To do so, I use the get salary method defined in my superclass. So inside the get salary method from my subclass that overrides the get salary method from the superclass, I can very well call that get salary method from the superclass. So the work that is done, for example, to obtain the value of the salary of an employee, which might involve things as easy as reading a field or as complicated as looking up, in a database and stuff like that, no matter how much work is involved here, that's the beauty of abstraction. I call this method, I get as a return result the base salary, and then I can implement in my class lawyer the policy that, well, the base salary the salary of a lawyer employee is the base salary of an employee plus $5,000, for example. Okay, so this is how we can use both methods and constructors of a superclass inside our subclass. Now, what about fields? So the easy answer is we don't. How do subclasses use a superclass field? They don't. The exact rule is that subclasses are not allowed to use a superclass private field. Now, if the field is public, different, okay? But anything that you inherit in your subclass from the superclass that has been marked as private in the superclass, any private method cannot be directly accessed inside the code of the subclass, okay? Let's take a look at an example. Public class employee, so that's going to be our superclass, as always. Private double salary, so here's a field of type double that is marked as private. If in my subclass lawyer that extends employee, I try to write a method give a raise that takes as parameter an amount, and I say that now the field salary is increased by that amount, that's going to trigger an error, okay? So, you can see that this is really restrictive, okay? That kind of goes in the face of the whole idea of I'm going to extend the class employee, I'm going to build a lawyer, but I'm going to reuse everything that the employee had to offer, including, fields. So how can we actually allow a subclass to have access to at least some of the fields that we know we are going to have to be able to mess around with in the subclass. Well, there is another keyword. Keyword is protected. Okay, it's used exactly the same way that you would use public or private, but it offers a sort of intermediary, access policy. A protected field or a protected method may be seen for the field, or called for the method only by the class itself. So it's very much like private with respect to that, or its subclasses, or classes in the same package. So we haven't talked much about packages in those videos yet, but let's leave it at that for now. But more interesting for us in this specific lecture is we have all the benefits of private. So what is not written here is that, when you create an object of that class, you cannot just access the field. It's still very much private in that respect, but we open access to subclasses. So inside the code of the method defined in the subclass of my class employee, I'm going to be finally able to access the field salary if it's defined as protected instead of private. So the syntax is very simple, okay? Instead of doing public and declaration of a field, or public and a declaration of a method, or even private, you do protected. You change the keyword that you use here as access. And that's it. Here's an example. So we were talking about the private double salary field of the class employee. Well, now we put it as protected double salary, and the subclass lawyer is going to be able to use this field, access that field directly without any problem. So what about constructors? Well, there are a few more things that we need to talk about concerning constructors. Let's take a specific scenario here. We replace the constructor that has no parameter with a constructor that requires parameter in employee. So in our superclass, okay? So far we had the class employee, we had the class secretary, lawyer, etc. And our constructor in employee didn't take any parameter, and therefore all the constructors in the subclass were not taking parameters, and everything was working. But then suddenly, if we make this one change, our subclasses do not compile. Why? So first, this is a message that you're going to get, okay? So why isn't it working? What can we do to fix that? Well, let's start with the solution. The solution is that if we write a constructor that requires parameter in the superclass and replace, with that new constructor, the one that didn't require any parameter, then we must rewrite all the constructors in all of our subclasses, employee subclasses, okay? And we need to make them so that they accept also a parameter, and then they call the superclass constructor with that parameter. And that's the crux of it, okay? The crux is that there have been some assumptions so far, and now the assumption being that we have no parameter, and now suddenly employee requires a parameter, so all the subclass need to require also a parameter for their constructor, okay? They need to call the superclass constructor with a parameter, so this parameter has to come from somewhere. The underlying rule that creates that weird situation is that constructors are not inherited. Okay, methods are inherited, fields are inherited, constructors are not inherited. So, for example, when we define the subclass lawyer, it does not inherit the employee constructor. So, for example, if we add in the class employee constructor with an int parameter, maybe represents the employee ID or the salary, whatever, well, the subclass are not going to automatically have an a lawyer constructor, for example, that takes an int. Okay? Instead, what Java does is, as you define a subclass, if you do not write any constructor, Java is going to provide a default constructor to that subclass. And the only thing that default constructor does, if you had to write it, would be, here's the name of the constructor, lawyer, and it calls the constructor from the superclass. The default constructor takes no parameter, and it assumes that there is a constructor in the superclass that takes no parameter. And this is fine if the superclass has indeed a constructor without parameter. Now, if our superclass has a constructor with a parameter, like an int, for example, this is not going to work, because when we call super in the default constructor provided by Java. It looks for a constructor in the superclass that has no parameter. It only finds a constructor that has one parameter. That's not the same thing. I cannot call that. And that's why we have this problem. Okay? So when we in our scenario, when we started with employees, the employee class having a constructor without parameters, so there was no int here. And then we had all of our subclass, even if we didn't write any constructor in the subclass, because the default constructor assumed no parameter, it worked. As we modified the employee superclass and required from its constructor to take a parameter, there was no longer a constructor without parameter in the superclass, therefore all those calls fell short. And this is a source actually of our bug, of our error, the error that we saw in the previous slide, okay? So this is a syntax to refer to the superclass constructor, okay, to call the superclass constructor inside the subclass constructor. So we already covered that, okay? Here's an example that we're going to use. In this case, if you want your lawyer class to be compatible with the employee class, okay, assuming that the employee class now features only one constructor that takes an int parameter, you are going to have to take an int parameter here and pass it to the super. This cannot be written automatically for you by Java. Java is not going to provide you with such a default constructor. You are going to have to write it. So if your superclass has constructors that have parameters, you have to write all of the constructors in your subclasses and make sure that they call the superclass constructor with the right parameters, okay? So you can get that parameter as that parameter that you pass here to the superclass constructor, years. You can get it as a parameter of your constructor for the subclass. And that's actually the only way you can get it. I was going to say, or you could generate it somehow here, but no, you can't. You can't actually have some code between public lawyer, let's say no parameters, and super years that would actually assign a value to years, because the super call to the superclass constructor needs to be the first thing that happens in your constructor. So I guess, I didn't test it, but I guess you could say super and specify a number of years here, if that's what the constructor of the superclass needs. So we could have a public lawyer, no parameters, opening curly brace, super, and then 10 years. So we put a value directly here. But that means that every lawyer object we create would pass the same parameter to the superclass constructor. So it's kind of a contrived example here. I'm just using it to illustrate the limits and the weirdness between quote, of the syntax here and the constraint that we have. But the most generic case, and 99.999% of the time, what you want to do is, if your superclass constructor requires a number of years, ask for it as a parameter to your subclass constructor. So when I create a lawyer, I specify the years are passed to the class employee, superclass employee. And that's how you're going to use it most of the time.